Hello everyone, this is Sai Sri from section C, pin number 22955A0517. So we're going to discuss the topic about cache only memory architecture. So first, why cache only memory architecture? Because it has good locality, adapts to dynamic scheduling, runs non-uniform memory access and uniform memory access optimized programs well, and useful when communication latency long. And why the hierarchy? It is for scalability and use for Snoopy protocol. So now let's know more about cache-only memory architectures. Cache-only memory architecture takes the extreme approach, that is no local memory and a very large remote access cache. The cache is known as an attraction memory. Overhead issues that must be addressed are need a much larger tape space, more care while evicting a block, finding a clean copy of a block, and easier to program. Data need not to be pre-allocated. And next, here is a block diagram of cache-only memory architecture and some information that is data partitioning is dynamic and implicit. Attraction memory acts as a large cache for the processor. Attraction memory can hold data that the processors will never access. Think of a distributed file system. USB can give UMA and performances on UMA architectures. So here is a block diagram which consists of a network, attraction memories, that is cache processors. So next we are going to discuss about data diffusion machine, DDM. It is an implementation of cache-only memory architecture, relies on hierarchical network structure. Large hierarchical machines can be built from small single-bus DDM machines. Cache coherence protocol modeled after the write once protocol. And here we can observe a small block diagram of data diffusion machine with some information. That is, the directory hierarchy allows scaling to attributary number of processors, branch factors and bottlenecks a consideration. Hierarchy can be split into different address domains to improve the bandwidth. In the diagram, we can observe the boxes containing of three letters that are A, D, A, M and P, in which D means the directory, A means attraction memory, and P is the processors. Next, we are going to learn about the cache only memory architecture performance. So the attraction memory reduces the frequency of remote access by reducing capacity, conflict misses. Attraction memory access time is longer than local memory access time in the CC NUMA case, since the latter does not involve tag comparison. Cache-only memory architecture helps programs that have frequent capacity misses to remotely allocated data. So the next we can see is cache only memory architecture prototype, in which it consists of a DDM bus, that is data diffusion machine bus, and memory, that is attraction memory data interfaces, that are SCSI, TTY, Ethernet, and we have caches, processors, node controller and attraction memory state. So this is a basic cache-only memory architecture prototype. The next is cache-only memory architecture implementation. So even though the memory block has no fixed home, the directory can continue to remain fixed. On a miss or a write, contact directory to identify valid cached copies. In order to not evict the last block, one of the shares has the block in master state. While replacing the master copy, a message must be sent to the directory. The directory attempts to find another node that can accommodate this block in master state. For high performance, the physically memory allocated to an application must be smaller than attraction memory capacity, and attraction memory must be highly associative. So the next is a simple structure of cache-only memory architecture. It consists of a processor, cache, and processing element node. So basically it is an interconnection network in which the processor from 0 to the nth, that is P1, P2, continue to the P of n processors, and it also consists of caches from cache 1 to the nth number of caches. The both processors and caches are located in a processing element node. Now we're gonna discuss about a simple cache only memory architecture. SPM takes advantages of virtual memory to provide easy implementation of address translation, replication, and replacement. These can be applied to the cache-only memory architecture. A simple cache-only memory architecture is if virtual addresses translation fails, the OS generates a local copy of the page. When the page is replaced, the OS ensures that the data is not lost. If the data is not found in attraction memory, hardware is responsible for fetching the relevant cache block from a remote node. Note the physical address must be translated back to virtual address. And the next is a basic comparison, that is advantages and disadvantages of the cache only memory architecture. First, let us talk about the advantage of cache only memory architecture, that it could reduce average cache miss latency due to improved locality. And the disadvantages of cache only memory architecture is it could increase average cache miss latency due to the hierarchical directory structure, and replacements can be tricky. So the conclusion, that is, the cache-only memory architecture is middle ground between uniform memory access and non-uniform memory access. In the prototype, overhead is 16% in access time and 6 to 16% in memory. Programmer productivity improved by not worrying about the non-uniform memory access issues.